All right, hey guys, let's take a look at now we talked about vertical dilations. Let's discuss horizontal dilations and kind of like the difference between the two. So, vertical dilation we discussed was when you took something and we multiplied the whole function by a factor of it. So, if I take this one and I go y equals 1/2 and then x raised to the power of 2, or s to the power of 2. I guess it doesn't really matter what it is. All right, we discussed that, and what that does is that cuts this distance in half. So the vertical distance in half, just like what it would show. So up here, your vertical distance from the original graph to the x-axis was 4 units, and when we cut it in half right there, it suddenly becomes 2 units. So now when we talk about doing horizontal, we're going to look at that, but it's going to be in relation to this. Because if you look at it, it's going to be in relation to the y-axis, right? And so let's just kind of take a look at sort of what that looks like. All right, so got x squared. And then when we write a horizontal translation, the way you're going to be able to tell the difference is the translation will be inside pair parentheses. So I'm going to show you what 1/2 x squared looks like when it's in there. So it'll be 1/2 x, and then that whole thing is raised to the power of 2. Okay, and it looks kind of the same, but it's really not the same. So the difference is, like, if I do the vertical check, even though it's a horizontal one, and just to show that it's not the same thing, I do a vertical check, you can see it's not 1/2 of this, is it? It's 1/4 of that. This is 4 and this is 1. But seeing as it's horizontal, and I told you we should check it in relation to the y, so let's do that. Well, from our original, if we go to this point right here at y equals 4, our x, it goes over 2, right? It goes from 0 to 2. Our change in x is 2. Well, if you look at from the y-axis all the way over to the transformed graph, it's been basically it's been doubled. All right, so it's kind of like a weird misnomer, but it does sort of the opposite of what you think it's going to do. So that's sort of a way of thinking about it. And so the language they use is they say, okay, what I've done is I went from having this opening right here. I'm just looking at where y equals 4. I have this opening right here, and I have stretched it. I've stretched it horizontally. In other words, its horizontal distance now has been stretched. It's now longer. So that's what they mean when they talk about, stretching and compressing. So this would be a stretch. And then if we want to look at an example of a compression, all right, that would be making this number inside here bigger than 1. So if I make it 2, then kind of the opposite thing happens, right? You look at this is still 2 units from here to here. And now it's been cut in half. So like I said, it's sort of the opposite of what you think would happen. So these are a little bizarre and everything. And I would really kind of recommend that when you're doing these, to kind of get your head wrapped around what happens, go to Desmos and play around with these if you're able to, because that's a really good hands-on way to sort of get an idea about what the heck is really happening with these things. So let's just do one more quick example and kind of look at what it would do. So supposing I decide that, okay, what is the difference between doing a vertical, right? Let's take this and let's make this 3x squared, all right? So you see the way that looks right there, right? Because you've stretched it vertically. So now this went up 4. My guess is it's going to be 12 where you get up here, and lo and behold, there it is, right? And so if I change this now to a horizontal translation, in other words, I put this 3x inside the parentheses, it completely changes it. And so what it does is it takes this distance that was here and it cuts it by 1/3. So if we find one that looks kind of neat, so let's look right here. This looks like it's approximately about 6 from this point to this point. And then this one is 2. So it's kind of wild how this stuff works, but there is some reason to it. So I hope this helps you a little bit. Like I said, go to Desmos, play around with these things a little bit so you sort of understand them more.